Friends, let's look at today's daily challenge problem. Count substrings containing every vowel and key consonants. This is the number 2 of such problems. So in this video, we are going to explain how to do it using two-pointer sliding window method. And also we need some idea from math, that is the set, right? So here the problem statement is rather short. Let me go over through it. So here we are given a string called word and a non-negative integer key. We want to return the total number of substrings of word that contains every vowel at least once and exactly key consonants. So this is a problem statement. Here are the 3 examples. You can go over it. So here the length of this word can be up to 2 times 10 to the power 5. In other words, we need to think of time complexity when we do the coding. Here, the point, the difficult point is this assumption. So exactly key consonants. This makes the problem a little bit harder, right? So in order to do this, actually we cannot count directly. We need to use some complement arguments. So the complement argument is the following. So here I just want to give you an example. For example, you have strings of length at least 2. So you are going to have, let's see, this set AB and AC and say ACD and ABCDEF, right? So then if we consider the subset, so strings of length at least 3, so the subset will be ACD, right? And ABCDFED, right? Then if you consider the difference set, let's call this one S1 and this one S2. Then the S1 minus S2 is nothing but AB and AC. So containing strings of length exactly 2. So this is exactly what we are going to use in this problem. So with that said, let's look at coding. So here our plan will be the following. First, we are going to write a function, hyperfunction, that can get a count of substrings with all vowels and at least key consonants. So let's call this function f key, right? Then what we want to return is nothing but fk minus f k plus 1. So you can make a comparison of this complement argument at this one here. So let's do the coding, and in between, we are going to explain the logic. So first, I'm going to get some variables that are common. So first, the length of this verb, and also we need to have a set that is vowel. It's vowels. So let's hard code it. All right. So with that done, let me first get a function called let's see, get at least key, right? So this is a function. You can think of this as the f here. So basically, our idea is that for each left index, so let me explain here, two-pointer sliding window. So for each left index, L, we want to find the least, the smallest, right? Right index R, such that the window, so let's say word from L to R, both inclusive, contains at least contains all vowels and at least key consonants. Then, starting from this index, you can choose to endings at r and r plus 1 at n minus 1, right? So they can count the number of valid such substrings starting at index L. If you can do for all L's, so you're going to find this F key, right? Then you can also find F key minus 1. Then you do the difference, you get the desired return. So this is our purpose for writing this hyperfunction. So let me initialize a result variable whose final state is what we want to return in this hyperfunction. And also we have a window. It's a counter. Let's call collections counter. So basically we want to monitor the vowels using this one. And n consonant. So this needless to say monitor the consonants. And then we can initialize initialization for the right pointer. Then we're going to do a for loop for left pointer in this range, right? Then we're going to do a while loop that is standard. So while r is less than n, it means that r is inbound. And so either the length of this window is less than 5. In other words, we don't have 5 vowels all appear in the window yet, or in consonants is less than k. So in this case, we keep shifting r to the right. So here, if word r in vowels, in other words, this is a vowel, and then we are going to do window word r incremented by 1. Otherwise, so it's a consonant. So we're going to increment this one by 1, right? So afterwards, so we need to shift r to 1 unit left. So this is actually the pushing the r to the right. And then basically we count if we have valid substrings with all vowel appear and at least n consonant. So here is a if check. If length of the window, because we have at most 5 vowels, so this is a condition, and n consonant is greater than or equal to k. Only these 2 conditions simultaneously hold, we are going to have valid strings, substrings. So the counting is important. So here, because due to the way we write the code, so r plus 1, the current state of r actually already invalidated this part, right? So if you count, so the value, if this condition holds, actually the endings of the possible strings, substrings, are actually the current state minus 1, then r, then up to n minus 1, right? So this is the condition. So the count would be this. So the endpoint minus the start point plus 1. That's the count. So this actually finishes the update of this result variable and pushing the right pointer to the right. Pay attention to this part. It's not n minus r. But here, if we state like this, so the count will be n minus 1 minus n minus 1 minus r plus 1. But this r is exactly making it hold, right? So the current state of r exactly making it not hold, right? So we're going to get this one. So then we are going to push the left to the right to check for every left index. So in this case, because we are writing in a for loop, not in a while loop, we just need to update the dictionary counter and this dictionary and this one, right? Let me update that. So here, if word L in vowels, in other words, it's a vowel. So we're going to do window word left is decremented by 1. However, notice that we're having this condition, right? So we need to make sure if a vowel, the count is 0. We need to that key not present in the dictionary. So we're going to do this. If this equals 0, then we're going to put down this key. This is important. And otherwise, if it's a consonant, because we are going to shift our one unit, so we are going to exclude the current one. Then we're going to consonant decrement by 1. So this way, after the for loop, we are going to get the valid substring with all vowel appear at least in key consonant. So we're going to return the result. So this actually finishes the major work of this problem. Then we just need to call this function. So what we do is return, let me copy this one. Then +1. So this will be the full code for this problem. Let me first test it. In consonants not defined, let's see, plus is s. Yeah, it passes the 3 test cases. Now let's look at the generic case. Yeah, it passes the generic cases. I guess with that passed, let me make some comment. So here in this problem, so we are still using two-pointer sliding window method. This is a very common method for solving some problem related to array, related to strings. And here we need one more trick, that is a complement argument, like I demonstrated here, right? So if you can also see the fk minus fk minus +1, or here get at least a key. First call this function with respect to key, and then call it with respect to k+1, so that we can get the strings with all vowel appear, and there are exactly key consonant in each of them. So with that said, I guess that's it for the current video. If you find this video useful, you're welcome to look at other videos in our channel, or share the channel with your classmates, friends, or who might be interested in. Thank you.